Hello friends. So in the last video you have seen how to calculate the lateral pressure in a sheet pile, cantilever sheet pile, and how to calculate the depth of embedment. Today we will take one example on cantilever sheet pile, and we would like to draw the pressure distribution diagram and to calculate the depth of embedment. So there is an example on cantilever sheet pile. Say this is the cantilever sheet pile. Having the backfill, which is going to be sandy soil, and the we need to calculate the depth of embedment for this cantilever sheet pile. Let's say the height of this cantilever sheet pile is 5 meter. So, and the water table is at a depth of 2 meter from the top of the backfill. So there is 0 meter, there is 2 meter, and total height is 5 meter. So here this becomes 3 meter. And the depth of embedment we need to calculate. So first of all, let us have the properties of the backfill. It is sandy soil, and the unit weight gamma above the water table is 18 kilonewton per meter cube, and below the water table gamma saturated below water table is 20 kilonewton per cubic meter. The angle of internal friction phi prime is 30 degree. Therefore, Ka equal to 1 by 3 and Kp equal to 3, where K and Kp are the coefficient of active earth pressure and passive earth pressure. So here there is also sandy ground having same value of phi equal to 30 degree. So knowing the properties of the backfill and the ground, here also gamma saturated is 20 kilometer per cubic meter. So if you want to draw the pressure distribution diagram across the cantilever sheet pile of height 5 meter, here let us see the solution. The solution here, you see, here h1 equal to 2 meter, that is the height above the water table, and H2, the height below the water table is H2 equal to 3 meter, and H1 equal to 2 meter. So total it becomes 5 meter. Therefore, the pressure is going to be hydrostatic. So it will move like this, it will vary like this, and the pressure you can calculate. Let's say the pressure at 2 meter from the top of the backfill we can calculate the pressure, lateral pressure P1 prime, which will be given by the coefficient of active earth pressure K into gamma into the height H1. Now K for phi equal to 30 is already known to you. Therefore, P1 prime equal to 1 by 3 into gamma is already given as 18 multiplied by 2 H1. So it becomes 12 kilopascal. So the pressure here is P1 prime and this is 12 kilopascal. Now below this, the backfill is submerged. So you can calculate the pressure below this. The pressure variation can be calculated here. So here the total pressure, let's say it is P2 prime. So at 5 meter depth, at 5 meter depth, the pressure is P2 prime, which will be equal to, here it will be, this variation is going to be, it is already P1 prime plus, it is going to be K into gamma prime into H2. So this will be K gamma prime into H2, and P1 prime is already 12 kilopascal. So 1 by 3, and gamma prime here will be, is given to you 20. So gamma prime will be 20 minus gamma W. So 20 gamma prime will be 20 minus unit weight of water, which is 9.81. So this gamma prime becomes 10.19 multiplied by H2 is going to be 3 meter. So into 3. So you can calculate this, and P2 prime will be known to you. So let's calculate this. So there is going to be 10 point this, 3 goes out. So it becomes 22.19 kilopascal. So P2 prime here, it is going to be 22.19, and this part is 12, and this part is going to be 10.19. 10.19. So 12 plus 10.19 total, it becomes 22.19. So P2 prime equal to 22.19. Now, you know that how the pressure is going to change now, because it has got rotation about the point O. So it is going to rotate like this. So this is the sheet pile. This will rotate like this about the point O. So naturally, the pressure is going to change. So it will go like this. So now this distance, if I call this the top as A, point A, and bottom as point B, and this, let's say, is C, D, D prime. Okay, then this OD prime becomes the distance A. So you have seen when I was explaining you the theory that how to find out this A. The distance A is going to be like this. A will be equal to P2 prime divided by gamma prime into Kp minus K, because it is going to be mixed one. Now here it is going to be passive this side, active from this side. So naturally the expression that we have already seen in our theory, and therefore we can calculate. Now P2 prime is already known to us. Therefore A can be found out 22.19. Gamma prime is also known to us as 10.19, and Kp prime will be 3 minus 1 by 3. So we can calculate this. So 22.19 0.816 meter. So this distance is known to us as 0.816 meter. This we have calculated it. Now, you have seen that the slope of this line, and therefore the is going to change like this, and this we can find it out, and the pressure distribution on both the sides can be calculated. So little modification of the, I will take it a little below. Right. So this becomes PP B1, and this becomes the pressure PP B2. And this distance O to B becomes Y. So for this triangle, we get this distance up to here. It is going to be capital Y. And the distance here, this distance is going to be Z. So this distance is going to be Z. So this becomes the pressure distribution diagram. Now, here at O, if you remember, the pressure is going to be here, PP at O. And I have already told you how to calculate PPB2. It's very simple because you know the slope of this line. In theory, we have explained it that one vertical, this is the slope is going to be this much, gamma prime into Kp minus Ka. So for one vertical, the horizontal is going to be this. So for y, it will be equal to, the value is already known to you as ppb2, and ppb2 can be calculated very simply from the slope of this line. So you can very easily calculate it as Kp minus Ka, or you can write it K prime into gamma prime into Y. So ppb2 is given by K prime into gamma prime into Y. And PPO, if you remember, is given by, this is also very simple. This is given as Kp gamma times H1 plus gamma prime into H2 under the water, and you will have to add to this K prime or Kp minus K, which is called K prime into gamma prime into this distance. So this PPO is also can be calculated by calculating it as Kp into gamma H1 plus gamma prime H2 plus K prime, because it is a mixed zone, active and passive. So it is going to be K prime, where K prime is known as Kp minus K. And Kp is 3 and K is 0.33. So it becomes 2.67. This is the value of K prime. So PP, once you know this, you can calculate PPB1 as PPO. So PPB1, the pressure here is PPB1, will be equal to PPO plus K prime gamma prime into Y. So friends, in my last video, I have explained all those things, how to draw the pressure distribution diagram. So it becomes quite simple. You know the expression, and already the pressure distribution diagram can be drawn. Here the value of A you have already calculated as 0.816. This is the value of A. Now, calculate this PPB2. So PPB2 and PPB1 can be calculated now. So let us calculate. So if you want to calculate this value of PPB2, it is going to be K prime, and K prime is 2.67 multiplied by gamma prime, which is 10.19 multiplied by Y. So you can calculate this in terms of Y. And PPB1 depends upon PPO. So let's calculate PPO. The passive pressure at O is called PPO, which is equal to Kp. Kp is already known to you. Gamma is already known to you. H1 is already known. Plus gamma prime is already known. H2 is already known. Plus K prime is 2.67 multiplied by gamma prime into A. So PPO can be calculated. The moment you calculate PPO, you can calculate PPB1. So PPB1, we can calculate it, and it will be equal to PPO plus K prime, that is 2.67 into gamma prime 10.19 multiplied by Y. Y is the distance from O to B. So let us put our calculator on and calculate 27.2 Y. And this quantity PPO will be simple PPO is 221.9. So PPO has been calculated very easily because all the quantities are known to you. Therefore, this is the value. Now, PPB1 is PPB1 is given as PP naught, PPO plus K naught gamma prime Y. K naught gamma prime Y. So let's calculate this. So this is 221.9 plus 27.2 Y. This is the value of PPO. This is the value of PPB1. So I know PPB1 now. I know PPB2. I know PPO. So I have been in a position to calculate everything. Therefore, I can now, and pressure distribution is also, so we can calculate now the area of this active earth pressure distribution diagram. So the area of ACDO will give you PA, the magnitude of active earth pressure. So let's calculate now this complete value. So the value P1 you have already calculated as 12. So this will be equal to, if I say this is 1, this is 2, this is 3, this is 4, will be equal to P1 plus P2 plus P3 plus P4. 4 areas, you will have to find it out. This P1 will be half into base is 12, into height is 2, this is P1. So you can calculate P1. Similarly, calculate P2, the area under 2 is going to be equal to, so this total, it is 12 multiplied by 3. So it is going to be 36. So P2, 12 multiplied by 3, now plus P3 will be half multiplied by base, which is 10.19, multiplied by 3 meter. So half into base into height. And this is the fourth area. This is going to be 22.19 multiplied by height is 0.816. And this is peak 4. So the magnitude of PA can be easily calculated. So if you calculate, let us calculate this. This is going to be 12. So P1 becomes 12, P2 is 36, P3 becomes 15.28 plus P4 is going to be 9.05. So you have been in a position to calculate the value of PA. If you add up, this will give you the value. So let me add this 9.05 plus 15.28 plus 36 plus 12. 72.33 kilonewton per meter length. The magnitude of active thrust. Now the point of application, if you want to find it out, this is PA. So with respect to O, let's say this distance is y bar. So I need to calculate y bar. Therefore, y bar also the point of application. PA now I know. Y bar will be P1 Y1. So P1 is already known to me. It is 12. And this P1 will be acting at 2 by 1/3 of 2, that is 2 by 3. So it is going to be Y1 is going to be 0.66 and plus this 3.816. $4.48. So this becomes P1 and this becomes Y1 plus P2 Y2. So 36. Now Y2 with respect to O is going to be the second figure, this one. So it is going to be 1.5 plus 0.816. This gives you 2.31. So this becomes P2 Y2 plus. Now P3 into Y3. So this will be at 1/3 of H2, that is at 1 meter. H2 is 3 meter. So 1 meter, and this becomes 0.816. So 1.816. So P3 Y3 plus P4. Now P4 is 9.05. So 9.05 into, from O, this will be 2/3 of 0.816 divided by PA. So PA is or P1 plus P2 plus P3 plus P4, that is 72.33. So in meter, you will be getting the answer. So let's calculate this and get the answer of Y bar. So friends, let us calculate. So we can calculate this. 12 this is 2.344. So the value of Y bar is calculated as 2.34 meter. So this Y bar is calculated as 2.34 meter. So the magnitude of everything we have calculated, PA is going to be 72.33 and Y bar 2.34. So we have been able to calculate this. Now, friends, you can find out the value of sigma h, the algebraic sum of all the horizontal forces must be equal to 0 for static equilibrium. So let's calculate that. So if you want to calculate, so applying sigma h equal to 0, algebraic sum of all the horizontal forces must be equal to 0, then this will give you the value of Z. And if you remember my video, Z can be calculated as ppb2 So you are going to get this value uh, ppb2 into y minus 2 times pa divided by ppb1 plus ppb2. In my last video, I have given you that if you equate this sigma h equal to 0, z can be computed from this. Now it becomes quite simpler. Now you see ppb2 is already 27.2. So 27.2 times y into y becomes y square minus 2 into PA, and PA is 72.33. So 2 into 72.33, 144.66 divided by ppb1. Now ppb1 is already you have calculated as 221.9 plus 27.2 times y plus ppb2. So that is plus, so it becomes 2 times. This is the value of z. So you have been in a position to calculate this value. Now, if you take about the bottommost point, that is B, the moment, and applying the law of statics, sigma mb must be equal to 0. Then you land with the value that PA into y plus y bar minus half into PP B2 multiplied by y into y by 3 plus half PP B1 plus PP B2 into Z into Z by 3 must be equal to 0. This is the sigma MB equal to 0. Now PA is known to me, Y bar is known to me, PPB2 is already known to me in terms of Y, PPB1 is also known to be in terms of Y, Z also in terms of Y, Therefore, friends, you will get one equation in terms of y, and therefore you will be able to calculate this y. So for this triangle, the y value, this is the y value, sorry, this is the y value from here to here. O to B will give you y. A is already known. So just solve this equation and get the value of y. So in a simplistic manner, we can calculate the, so friends, this equation from sigma mb equal to 0, solve this equation. So solving, let's say this is the equation to solving 2 for y, we get the value of y. Therefore, depth of embedment d equal to y plus a. In certain situation, if you feel that the passive earth pressure is not going to develop fully, then you can also apply a factor of safety to Kp value. And then you can find out Kp prime. This way, we can attempt this problem and completely solve it. Once we get this, the depth of embedment is known to you. Increase this depth of embedment by 30%, and the depth to be provided, this is for factor of safety equal to 1. So you can find out the value of depth of embedment. So I will take few more problems in my next video and explain to you. So friends, I hope you must have understood it nicely. Thank you very much.